Hi everyone, this is lesson 2.2.2 on similarity. This continues our discussion on dilation that we had on a previous lesson. So this is what kind of summarizes what we need to know. We're looking into similarity so we could understand how to really find missing measurements in when we compare similar shapes. So here's a definition. I think it's been mentioned before. If two polygons are similar, like let's say we already know they are similar, then this is what we know about those two shapes. All pairs of corresponding sides, meaning sides that are in the same location, that's what corresponding means, are proportional, and I'll explain what that means in a minute. And all pairs of corresponding angles are congruent. All right, so you should be familiar more so with the last one, meaning all their angles, corresponding angles, meaning the angles in the same location, will have the same measurement. Okay, so today we're going to mainly be talking about corresponding sides being proportional. All right, in the last lesson we talked about dilations, making a shape bigger or maybe even smaller. And I mentioned some terms last time. I just wanted to review that. This is kind of going to come in a little bit more useful in future lessons. And so what I wanted to reiterate was our use of the term scale factor and zoom factor. So they pretty much mean the same thing, except how we write them tends to be a little bit different. So if something was dilated, like sometimes we'll say, oh, it was 3 times bigger, or we made it 3 times bigger. Really what you're saying is it has a scale factor of 3. If we were going to put this in a computer or a copy machine, we would say we want it to be 300%. So that would be a zoom factor. And so you'll notice the scale factor is a whole number, whereas the zoom factor is a percent. So I gave you a couple other examples that sometimes come up. So sometimes things are not made larger, but in some cases they might actually be made smaller. So this would be an example of how you would make something smaller. So everything starts off at a scale factor of 1. So if it goes less than 1, then it starts to become smaller, it will shrink. So this is 0.5, which is also the same thing as 1/2. And so that should make sense because if we always start off at 100%, if I start off at 100% and I have half of it, I divide it by 2, this is going to give me 50%. All right, so 0.5 is the same thing as 50%. 3 is the same as 300%. And then it could also be written as a fraction as well. So it doesn't matter if it's a whole number, decimal, or fraction, which I've listed here for you just to let you know. The zoom factor will always be a percent, but the scale factor can change. It just whatever is convenient. The problem might give you something different, or maybe whatever you feel like writing. 3/2 would be the same thing as 1.5. So if I wanted to write that as a decimal, I could also write it as a decimal. And so you'll notice it looks very similar to the 150%. All right, so there's the 1 and the 5 come from that decimal. Just like there's a 3 is 300. And then you'll notice this 5 in here, that's 50. Right? And so all these numbers are connected. I just wanted to review that so you have that in your notes in case you need to look those terms up. All right, so as far as checking for similarity, one, we're trying to see, we're going to be looking at are shapes similar or not, and then if we know they are, can we find missing side measurements? All right, so here's kind of the first part of it. I'll show this much. All right, so here we have a given, 2 given shapes to us. So they kind of have this C, they both look like the letter C. And we're going to compare these two shapes. And when we compare them to see if they are similar, we're really looking to see if the sides are proportional, and that was mentioned earlier. So we compare these our side lengths by writing a proportion, all right, which is really just saying we're going to set two fractions equal to each other, right? Another word for fractions is ratios. So make sure you're familiar with these words: proportion, ratios. All right, so looking at our two shapes, I have some measurements. We have 24 and we have an 18. We have an 8 and a 6. And so what we're going to do is compare the heights. So the heights of both of them, these would be corresponding sides because they're in the same location. So I'm going to compare 24 and 8, and I compare them by writing a fraction, 24 over 8. And then I want to compare not the heights, but maybe the widths. These are also corresponding because they're in the same location. They're both at the bottom. So that's what we call corresponding sides. So I'm going to take 18 and 6. You'll notice the arrows, meaning I'm going to start with 18 and then I'm going to put 6 underneath it. So 18 over 6. Same thing with 24 over 8. All right, so the question is, does 24 over 8 equal to 18 over 16? Now the numbers don't look the same, so really my first thought is these are probably not the same. All right, so in order to understand that, we set up a proportion. Okay, so this is what a proportion is. It's two fractions equal to each other. All right, each one, this is a fraction. It's also known as a ratio. This one's also a ratio. Right, ratio just means fraction. And so I'm setting these two fractions equal to each other, and I'm going to compare them that way. Okay, so if these two fractions are equal to each other, then I could say these two sides we could say these corresponding sides are proportional, which could lead us into either proving that they're similar if we didn't already know that they were. All right, so if we simplify both of those fractions, you could even put those in a calculator, or maybe we could do some other approach to it. You kind of have a few options on how to simplify this, but for the most part, I'm going to reduce this fraction. Right, I'm just going to reduce it, and it reduces to 3 over 1. And then I'm going to take 18 over 6 and I'm going to reduce this fraction, and it's going to be 3 over 1. So I notice both of these equal to the same thing, right? Hence the check mark. So when this is true, 3 over 1 is equal to 3 over 1, then we could say the sides are proportional. Okay. So that's kind of like an overview of what we're doing. This will make more sense when we actually practice this in the next problem. This is just kind of introducing you to terms: proportion, ratios, setting up a proportion, what that means, comparing sides, corresponding sides, knowing where they are. So we're going to do a couple problems. So in the next one, what I'm going to do is take a very similar shape, and we could use our proportions to help us solve for missing measurements. So what we're going to do is, I'll stop right there. So we have a similar shape, except you might notice we have some different measurements. So I have a 20, and I have an 8, and I have an X, and I have a 6. So if I already know these shapes are similar, then that means one of them is a dilation of the other. It just got larger. Now, on the previous example, you might have been able to see, oh, let me go back. So in the previous one, you might have been able to see like, oh, 8, 24. This is like 8 times 3 is 24. 6 times 3 is 18. Oh, that's easy. I know the scale factor is 3. But in some cases, it's not a nice whole number. All right, so when we look at a problem like this, 8 times what is going to give me 20, that's the confusing part. All right, so it doesn't always work out to a nice number, which is why we want to learn how to write a proportion. All right, so what we're going to do is I'm going to take these corresponding sides and write fractions. So this is going to be 20 over 8, and this is going to be x over 6. You'll notice we have an x, we don't have a number there. Our goal is to figure out what x is. All right, so once I have those fractions, I could set them equal to each other, and that is what we call writing a proportion. So usually on a test, if you could do this part, you've already earned points. All right, so that's kind of the major thing that I'm looking for. Can you set up an equation? The next part would be actually solving that. So this might be something you're already familiar with. So one approach is what we call cross multiplying. So if we cross multiply, which means we're going diagonally, we're going to multiply those numbers. So I'm going to take 8 and x, and that's 8 times x. You'll notice I'm putting parentheses just to kind of separate them. And 6 and 20. So 6 and 20. All right, so the next line, I kind of just simplify it. 8 times x is 8x, and 6 times 20 is 120. Now, my goal is to figure out what x is, so I divide both sides by 8, and this gives us a nice number. All right, so that gives us a 15. So that means this x is equal to 15. All right, there's no way I would have guessed what that number is. All right, so that's pretty much the type of problems we're going to be working with, where you're going to set up a proportion, you're going to solve it, and get an answer. Right? This is pretty much a test question that you might see. The only thing that might change is maybe I'm going to give you 2 triangles instead, right? Instead of this weird C shape. All right, and so this is the last problem we're going to do on this lesson. It's a little bit more challenging, but it kind of follows the same pattern of work. And so the first thing is, just to kind of review, why are these 2 triangles similar? Well, it's not mentioned. It's mentioned in the book's problem, but there's actually 2 triangles here in case you can't see them. There's a large triangle, ABC, and this triangle has been dilated to be smaller and turned into a B prime, C prime, right? So a smaller triangle. So there's actually 2 triangles in here. And so let's write a similarity statement. And so kind of just to answer the questions, why are the 2 triangles similar? I'm just going to answer this for you. This is, let me write this better. So triangle A, B prime, C prime is a dilation of triangle ABC. All right, so that pretty much means we could say triangle A, B prime, C prime is similar to triangle ABC. All right, so you'll notice the notation here. I'm using the similarity notation, which is a little squiggly line. Right? We've seen this before with our congruency. Congruency had an equal sign with a squiggly line on top. This is just similar, so it just has the squiggly line. All right, so now let's use a proportion to solve for x. All right, so this looks complicated. Usually people will make mistakes on this one, and the best suggestion I have for you on this one is to separate the 2 triangles. All right, so I've started that process already for us, and so what I'm going to do is I redrew these and I'm going to relabel them as well. So on the smaller triangle, in our smaller triangle, which is A, B prime, C prime, opposed to A, B, C, I'm going to include the measurements for the small one, which is 4 and X, right? 4 and X. Now on the big one, this is usually where mistakes happen. So from A to B, if I want to go from A to B, what's that measurement? Now a lot of people will say, oh, it's 6. The small one is 4 and the big one is 6. But it's 6 from here to here. So be careful there. You have to add 4 and 6 together to give you the total distance. So I'm actually going to write that out. This is actually 4 plus 6. 4 plus 6. Maybe I don't want you to get confused. That's a plus sign. So I'll write it like this. 4 plus 6. All right, and then on the other side, same thing with the other side, I have an X and I have a 9. So the total is going to be X plus 9. All right, so that I'm going to write that. X plus 9. X plus 9. All right, so now that we're clear on what the measurements are, now we're going to set up a proportion, which means, again, it just means 2 fractions equal to each other. So usually right away I just start with this, the fraction bars and the equal sign. So I just need to match up the corresponding sides. So I'm going to start with AB corresponds with, or AB prime corresponds with AB. So I'm going to make a fraction using those. So I'll put the bigger one on top. So 4 plus 6 over 4. And then I'm also going to put, let me use a different color. 4 plus 6 over 4. And then the second one we're going to do is the second side. So I'm going to do from A to C. These are the other corresponding. All right, so this is, let's go with the bigger one on top. So I'm going to put X plus 9, and I'm going to put X. All right, so this looks definitely a little bit more complicated, but it's the same process. We're still going to cross multiply to solve. Now, if you could set this up, that's already huge. That's a big step if you could just do that much. So then we'll do one step at a time. I'm going to zoom into this. So I'm just going to add 4 plus 6 is 10, and this is 10 over 4, and I'm just going to do, that's the only thing I'm going to do first. All right, so the next step, I'm going to cross multiply. All right, so I'm going to multiply these, and I'm going to multiply these. All right, so that's going to be, I'll do 10 times x is equal to 4 times x plus 9. All right, this is where your algebra skills need to kick in. Now, just to kind of simplify this is going to be 10x. I'm going to get rid of the parentheses. This is where mistakes usually happen. Make sure you distribute the 4. So 4 needs to be multiplied to x, and it needs to be multiplied to the 9. All right, so this is going to be 4x plus, what's 4 times 9? 36. Right. All right, so at this point, I think that's the hardest part. The rest should be a little bit easier. We could subtract 4x from both sides, and then you're going to be left with 6x equals to 36. All right, and so what is x going to be equal to? Well, the last step is going to be, do I have room here? This is going to be 6. We're going to divide both sides by 6. So then we're left with, let me shrink this. All right, so let me reskyze that. So then we're left with x is equal to, x is equal to 6. All right, so it should look something like that. This is probably one of the more challenging problems, so if you understood this one, then you should be good with something a lot simpler, like the previous one. All right, that's it for this lesson. Let me know if you have questions on any of this. Usually people do. All right.